Yep. So good morning, students. And today we're gonna come back to SpaCy again. And here we're gonna just use a very simple example to demonstrate the use case of SpaCy using sentiment analysis. I mean, sentiment analysis is a little bit basic, so it serves as a very nice case study for us to understand the context on how we use SpaCy in a real prediction scenario, right? So in today, what I prepared is yep, we're gonna learn basic text pre-processing using SpaCy, right? Including how do we actually deal with stop words, punctuation, lowercasing, etc., and how do we incorporate that inside, for example, sentiment analysis, right? And then we're going to use TF-IDF to vectorize our information. Basically, it just remove very frequent words out of the database, in which TF-IDF is a normalized version of count vectorizer. And then we're going to use sklearn and then do some prediction in real world, right? So very simple use case for understanding SpaCy further. All right. So without further ado, let us start right away what we're going to do here. So firstly, we're going to, okay. So yep. So let us just start with loading our thing. Just gonna put it here, right? So first thing I want to teach is a lemma, right? In which a lemma is basically so if we have something like running, ran, right? The lemma of this is run, right? So it's the original root form of running and ran, right? So why do we need to always extract lemma sometimes, right? Well, because by turning all the words into lemma, you allow the machine learning model to not confuse between the different forms of lemma, right? So that is the idea, right? But of course, I just want to highlight here that if you're using a neural network, you don't have to really do lemmatization, because a neural network has the ability to actually understand the context right around, right? So it's better that you kept it in the form that you allowed them to understand the context. Yep, great. So we're gonna do import SpaCy, and then NLP equal to SpaCy.load and chord SM. And then doc equal to NLP running. And what we're going to do here is for token and doc, we can print token, and also the token.text, and also token.lemma. And you can see that by default, SpaCy, this pipeline already had something that allowed you to grab the lemma, right? So this is going to be useful for us when we pre-process text, right? So that is lemmatization. Let's look at stop words, right? So SpaCy also has a very easy way to detect stop words, and sometimes in a very traditional classic NLP, you would want to remove stop words, right? But note again that in modern neural network, you don't remove stop words because you will lose the context, right? But here, again, to demonstrate SpaCy, we're gonna remove stop words using SpaCy. And you may now have some weird idea that, hey, then why do we need to use SpaCy when neural network does not require removing this? Well, even not requiring that, by using this utility, you can do a lot of interesting things like analysis, right? Which will be needed in your research papers, right? So yep, so it's better to know what is available in SpaCy. Yep. So next thing is stop words, right? So we can say from SpaCy dot lang dot en dot stop words and import stop words. Yep. And so SpaCy has already a list of words that it provided, and now we can actually print the list of this, right? So we're gonna say stop words equal to list of stop words. We can actually print this out, and it's very long, right? And we won't print this now, right? So that is a list, and I'm going to print put more out around here, and then so now we can say doc equal to NLP. Chucky is going to Disneyland to eat with his best friend, Peter. All right. And then what we're going to do is a clean tokens equal to, so this is demonstrating how we can actually remove stop words, right? So we're going to say for token and doc, if token.text, not in stop words, then we're going to say clean tokens dot append token.text. Right, so you can see that a lot of stop word is being removed, like is, to, right? So this is like a very classic NLP in which you remove stop words and then you send this thing to the machine learning algorithm like support vector machines to predict, right? But in modern neural network, you don't have to. You just send this whole thing, and the neural network will be able to figure out everything. But anyway, this kind of simple code definitely will be useful in your analysis and also some pre-processing steps. Okay, great. So now we have learned how to actually remove stop words. Now we can also look at how do we actually remove punctuation, right? So for example, I have this kind of thing, Chucky, the teacher, and then I'm gonna have a lot of weird symbols like this, all right? Which I'm not sure where this come from. AIT, and then likes to eat sushi, right? And so we don't want this to interfere, right? So firstly, we don't want this to interfere our sentence, right? So what we're gonna do is firstly, you need to notice that we're gonna do something like this for print token dot text and token dot pos. Yep. So you can see that by default, SpaCy provide us something called part of speech, right? You can see proper noun, punctuation. Yes, punctuation. Oh, we got symbol. Sorry, and punctuation, right? So we can actually leverage this to help us remove them, right? So what we're gonna do is based on this, we're gonna say token no punc equal to that, and we're gonna say for token and doc, if token dot pos, right, underscore not equal to punc, right? So it should not be punc, and also token dot pose should not be equal to let's say okay, we don't have anything so we're gonna just put sim, right? And I think that's it, right? So by doing that, If they are both not equal to those, then we can say no punch dot append token dot text. Right. So once we do that, now I think it should look much cleaner, right? So you can see that Chucky, the teacher, add something. So we still have this weird thing, right? So let us take a look at what are those, right? So we can do for token in doc, right? Token dot text and token dot pos, right? So what are those? So those noun. Okay, great. So yeah, if we want to actually remove this, then we have to probably create our own tagger, right? This is not an entity ruler. This is a tagger to actually mark them as something that is not actually noun, but something else, right? But anyway, we're gonna let it slide for now, and assuming that it removes quite a lot of stop words, right? So yep, so that is removing, I mean punctuation, right? So that's done. So now the next thing we want to do is lowercasing. That can also be done very easily. Actually, it is not related to SpaCy, but rather basic Python script, right? So we're going to say script dot append, and here we can just say the lower dot text dot lower, so we can make it everything lowercase. Why do we want to make everything lowercase? Well, we don't want to cause any confusion to the model that hey, capitalized and lowercase is actually different, right? So by lowercasing, it helps the model understand things easier, and stripping, making sure that we don't have any extra space. Yep. So of course we can actually print this and take a look, right? And you can see that everything is lowercase, including my name. Yep. Great. So those are the basic thing. If we want to combine them into a simple pipeline, well, we can do this, right? We can do reprocessing and input sentence. So this is going to be used below here when we actually do sentiment analysis, right? So we're going to say stop words, go to list of stop words, and then doc equal to NLP sentence. And then we're going to say clean tokens equal to blank list. And then we can now we can perform for loop. Sorry. And if token dot text not in stop words, and token dot pos not equal to punk, and token dot pos not equal to sim. And I'm going to add just one more, okay? And token dot pos not equal to space. All right, and I think that's it. And then we're going to say otherwise that this dot append token dot text. All right, and then of course we can now return the clean tokens. Yep. But of course, if you here you need to notice that this function actually return a list, right? If you want to make it as the same sentence, well, you can just use dot join, something like that, right? That should be able to let you get back the sentence you want without all this stop words and etc. Okay, great. So we got this pre-processing, and now we are done with learning the basic things that SpaCy can help you. And with that, I'm not sure I can. Okay, great. So that is done. Now the next thing we're gonna do is sentiment analysis, right? So here, what we're gonna do is import various basic things. So firstly, pandas. We're gonna take out feature extraction, dot text, import DFID, vectorizer, not transformer. Yep. And then we're gonna also do pipeline for pipeline, and then of course trying to split the famous photo selection and for trying to split. And what else we need to do that from scalar.matrix, accuracy scored, classification report, and also the confusion metric. Yep. So those are very basic things we're going to use. So let us start loading some data, right? So here I have prepared some data. So I have some reviews in Amazon, right? So basically everything is followed by some sentence followed by whether it's a positive or negative, right? So I have from IMDb and also the Yelp, right? So they are all already making sure that they are in the same format, right? I'm just gonna load them. Okay, so I'm gonna do data Yelp equal to pd.read CSV and data Yelp. All right, and I'm just gonna add something. So separator is tab, and header is none, and names is equal to, just create the columns right away, and review, and sorry, review. I don't need this. And sentiment. All right. So that is the first one. I'm gonna have this 3 of them. Right. So just gonna quickly change this to Amazon. Right. And same for this one. I'm just gonna change it to what is the last one? IMDb. Yep. Okay. And little bit space to make everything looks nice. Great. All right. So let us enter and hopefully no problem. Yep. So that is done. By the way, I will make sure that I will put this information into some central Google Drive, so you can always download all this data. Yep. And then we now can do, we can take a look ahead. Right, and you can see that things are aligned nicely into a Panda, right? So review and then the sentiment. Yeah. And then what else we can do? Well, we can definitely check the shape, right? So data Yelp.shape, data Amazon.shape to check how many rows we have, and data IMDb.shape too, right? And you can see that we got 1,000 rows each for Amazon and Yelp, and 748 rows for IMDb. So we have quite a lot of data sets, right? So we can do a lot of interesting stuff, right? We can train our data on this two and apply and test on this one. It's called transfer learning. Or we can take some of each as training and some of them each as testing, right? That could be a good way of combining them, right? But there's so many ways you can think about that when you do machine learning, right? Yep. So I think that's it for loading data. So let us do some kind of simple EDA, right? So firstly, what I'm going to do is I'm just going to decide to combine all of them into one data set, and then later on split them into training, validation, and Amazon, and then IMDb. right? And we're going to see ignore index for true. Okay, great. So now we have all the data, right? So we have 2,748 data here. Next thing we can make sure is check imbalances, right? That is a good practice to make sure we are not the model doesn't just print one sentiment, right? So the data sentiment dot count values dot value count, sorry, and we can see that we got quite a good balance number, right? Even though it's not exact, I think this is fair enough for the model to predict, right? If you have like just like one, so many one, and like so little zero, the model just try to cheat by just predicting one and still get like 95% accuracy, right? So that is something we want to be careful, and we can do two things. We can either use something like downsampling or upsampling, or we can use F1 score, right? So those are something we can consider. Definitely, we want to check for any missing value, and I don't think we have that. Yep, great. So those done. Now we can actually learn something called column vectorizer. Actually, this is not within the scope of SpaCy, but anyway, since we're doing sentiment analysis, so why not we just learn it as a bonus? Yeah. So column vectorizer. So we're gonna say from sklearn dot feature extraction dot text import column vectorizer. Yep. So the idea is that if you just send this text into machine learning model, they can't understand, right? Because it's text, right? So you have to transform it into some feature. And one way you can do is counting, like, okay, this word, this count, this word, this count, and then send this table to the machine learning model to infer something, right? So count vectorizer is one, and TF-ID is another one, right? How about modern neural network? You don't have to, right? Because they can actually extract representations then that you can send to softmax layer, and then it can predict something else, right? So that is not needed. But we are talking about classic NLP, and again, even though we are not talking about like the best state of the art, right? These are still very relevant and modern and industry level NLP. Okay, great. So we're gonna do convec equal to convectorizer tokenizer. Yep. So now we are able to use the pre-processing function that we have created up here. Here, right? So we can specify that the tokenizer is basically the pre-processing before you actually do the count vectorizer. So now we're gonna do so we can actually have some examples, right? So you can actually understand what does it do. So we can say corpus equal to Chucky is coding Python. And we can do deep learning is fun. And we also can say SpaCy is cool and fun. And then please maybe please hashtag SpaCy. Yeah. Okay. I think okay. I think that's it, right? Yep. And then now we can do we can actually take a look at the result, right? So result of convec fit transform. So fit is basically learning some basically counting. Yep. And transform is basically transform them into some kind of feature vectors or feature tables, right, into results. Yep. So now I think we can now print convec dot get feature names. right? And we can also, so this is going to print the list of tokens, right? And we're going to also print result.toArray. Yep, it's going to actually print the actual results. Yep. Here, rows sentences, and columns are basically words. Yep, unique words. Yep. Right. So you can see that in the first sentence, we have Chucky, one coding, and I'm not sure what is that. That is Python, right? And then in the next sentence, etc. So we have 4 sentences, and it's just counting different. So you can see that count vectorizer is simply a counting matrix of the thing. And if you don't mind, you can just send this table to so you can send this vector, right? You can imagine that this is a table, right? With this is as the column, and this is a 0 and 1. So you can say, okay, this with this features, this is a sentiment of 1, for example. With this feature, this is sentiment of 0, for example. So you can similarly treat this as a X and Y, right? And then send this to SVM or whatever k-nearest neighbor random forest, right? And then it can predict accordingly, right? But again, count vectorizer may not be the thing that the best, right? Then you can definitely look at TF-ID. But before we go to TF-ID, let us do some analysis, simple analysis, right? So we're going to do import numpy as np, and we're going to say negative condition is data.sentiment. Yep, equal to 0, and positive condition is equal to data.sentiment 1. And now I want to get the negative df. It says basically the data with this condition, and then the positive data frame is basically data with positive condition. So what I'm doing is I want to extract all the reviews that is negative and all the reviews that is positive, right? Why do I want to do that? Well, I just want to perform some kind of analysis to understand what is happening once I do some counting, right? So what I can do is a negative result equal to count vec fit transform negative df dot review. Okay. And then the negative caps go to count vec get feature names out. Yep. So now we can actually print them out and see what are the common words in negative results, and what are the common words in the positive, right? So we're going to do the same for positive. So we're going to call this post. All right. And I think that's it. Yep. All right. And there's some kind of, it takes some time, hopefully not too long for our tutorial. If not, I'm going to pause my video. Yep. All right. So it's not that long, right? So now we can do negative result shape and post result shape. Right. So now we have 1,362 sentences, each with 0 and 1, right? 0 and 1 with 3,158 unique words, right? So that's a lot, but anyway, now we can actually print them out, right? So we're going to say negative sum, negative counts equal to np.sum, and result and x is equal to 0. So this is simply to count for later on some kind of counting. Okay, we're going to be using and then those counts np.sum those result, and x is equal to 0, right? So by doing that, we can sum all the unique words, right, for each of them. Yep. And then once we have that, now we can actually plot them into a data frame so that we can see them nicely. Yep. Negative counts columns equal to caps, so we can see them nicely. And then we're gonna just transpose sort values. Yep, this is a little bit because this is simply another way around. So I just transpose them to easily get by equals 0. So it's sort by the first column, and then ascending equal to false. Right. So we have the most negative word here, and now we are ready to actually take a look. Right. So df.head. Right. So it seems like in a negative review, we have one. I'm not sure what is that, right? So certainly we don't like that, but we have bad, we have good, not so good, right? So you can see that by doing simple analysis like this, which is very necessary, you can better understand what is happening, what is the most common words of in the negative data frame, and see whether it makes sense, right? In my case, it does not really makes a lot of sense, right? But of course, you can also change to positive, right? And you can see that, okay, I think okay, I should say positive all caps. Yep. And you can see that, okay, I haven't punched this one, and you can see that, whoa, when it's positive, you can get great, good, food, best, right? So for positive, it's quite okay, right? But for negative, that seems like the signal word is bad, right? I think, yep, the signal word is bad, but there's also something like good, right, which can kind of confuse the model, right? So yep, so this is a very nice way to actually understand whether the column vectorization is good. But let us visit TF-ID F vectorizer. I'm not going to go into mathematics because this is going to discuss in the lecture anyway. But basically, the idea is that we is something like a normalized version, right? In which we normalize across all the documents, right? So now we can take a look here. How do we do that? So we're going to just say TF-ID vec equal to TF-ID vectorizer, tokenizer equal to pre-processing. And then we're going to say negative result equal to TF-IDF vec dot bit transform. Negative df dot review, right? And we're going to say negative vocabs, right? This is for us to print when we print the data frame. And we're going to say tf-idf vec dot get feature names out, right? And we're going to do this the same for a positive. Okay, and then I think that's it. Now we can do the same. So give me 1 second. I'm just gonna cheat a little bit and copy what is already printed here. So I'm gonna copy this, and I'm also gonna copy this. So this is gonna be negative count. And similarly, I'm just going to copy this again. And it's going to be positive. Yep. Oh, I forgot this one. Okay. And once we do that, now we can actually take a look at what are the common words of in the negative and positive captured by TF-IDF, right? Which hopefully it doesn't have a very irrelevant numbers or values, words like a count vectorizer, right? So we're going to do count dot head 10, right? And you can see that it looks much better, right? Because it delete a lot of unnecessary things. So you can see how bad ways, right? But again, we still have this something called good, right? Probably it's have something like not very good, right? We of course we can take a look at those, and then now we have a grade. It still look very similar to count vectorizer. You may wonder like why this number look like this. Simply because there's some kind of equations that is provided that is given in the TF-IDF. Yeah. All right. So those that the TF-IDF. For those who are actually interested in the TF-IDF mechanism, actually I have prepared some appendix here in which I actually provide some actual calculation here, right? So you can take a look. It's actually very simple. Yep. Okay, great. So definitely you should take a look at them. Great. So those, I'm just going to close this to not distract our main purpose. And now once we have this, now we are able to start do some modeling and training, right? So we're going to use the famous sklearn, right? Well, it's a little boring, but I think it works very fine. From sklearn.svm import. So we're going to use support vector classifier. Classifier equal to linear SVC. TF-IDF vec equal to TF-IDF vectorizer. And then X is basically the data review. And Y is equal to data sentiment. All right, and we're going to do some simple train test split. I'm not sure I'm going to do like a very correct way of like doing things. Usually you want to split them like this first, and then under you want to do some cross validation. Train test split. X, Y, test size equal to 0.1. 0.3. Yep, and then random state equal to like anything is fine. Yeah, so the test size, yeah, if you have a lot of data, 0.1 is fine, but 0.3 is like the number I use a lot. Random state is just to making sure that every time you do this, the split is the same. Print xtrain dot shape. Right, so we have 1900, and then our test. Okay, we have 825. Yep. So once we have that, now we can create a pipeline, right? And in which our prediction pipeline, we're gonna pass to TF-IDF, TF-IDF wake, and then classifier. Yep. So we're gonna pass through the pre-processing, extract the features, and then send it to the classifier. Okay. And then the classifier is simply the linear SVM. Yep. Great. So now without that, we can just do this. Fit extend. By the way, actually, you may want to do some cross validation, all the best practice we learned in the machine learning classes, but But here I'm just gonna focus on SpaCy, right? So I don't want to talk too much about like all those things. But anyway, we just fit them. Yep, and we got some problem here. So okay, I should not do that. I should say Y train. Yep. And once we fit that, now we can do some prediction, right? So let me just enter a couple of lines. Y hat equal to CLF dot predict access, right? And based on that, now we can actually print some scores, right? So we can say classification report, Y hat and Y tests, okay? And yep, the score is not so bad, right? So it's able to learn some patterns in the sentence and predict it correctly. The right way of doing research is not only reporting this number in the papers, but what you want to do is probably analyze what are those 0.17%, right? So how to do that? Well, you just get those that are incorrectly classified, and then print them. What are those sentences, right? So those are probably the first step. Yep. Of course, definitely you want to do classify confusion matrix Y hat and Y test, right? And you can see that a lot of like there are 760 and 62 here, right? So definitely you can try to take a look at what are those information. Yep. Great. So those are our prediction. Very, very simple, right? Very simple sklearn. It can be oversimplified, but that is a quick way to see that, yeah, we can actually input those things that is pre-processed by SpaCy and then to internet. In the real world, we can definitely use the train model to predict whatever, like Chucky loves Spider-Man game in the PS5, for example. And then, yep, it can predict very quickly that this is positive, and let's say dislikes, and they can quickly say that is 0, right? Great. So I think that is all for the sentiment analysis. Hope you can better now understand how you can use SpaCy for very simple classical machine learning. Yep. Thank you very much.